It doesn't look like it, but this is a very sophisticated question. So, question, does a series converge or diverge? Now, be a little careful with this numerator. That doesn't make this an alternating series. So I can't use an alternating series test. After all, if n is equal to 1 or 2, both those terms are positive. I don't always alternate signs with each and every term. So it looks to me like the ratio test would be complicated by this sinusoidal function. Certainly the root test doesn't look like it applies. So I'm speaking the language of this last section in which we're not given any new techniques for testing for convergence or divergence. We're just simply putting everything together, looking at a series, maybe identifying whether or not I know a test to apply. So I'm playing a little bit of chess. So I do think the ratio test does not apply. The root test does not apply. Alternating series test does not apply. So I tell you what, I just give up. Instead, reconsider this series instead. If I can determine whether or not this series converges or diverges, can I take those orders back? If I can determine that this series converges, then this series converges absolutely, therefore converges. I have to spell it all out. Maybe I don't spell it out all the time with the ratio and root test because it's kind of like automatically built in. But I'm not using a ratio or root test, so I have to show all my steps. So here I go. I'll consider a whole new series, but this and this are intimately related. There's a relationship. That being the case, notice that that's the nth term. That's a p-series. With p being equal to 2, which is strictly greater than 1. That being the case, this series right here converges by the comparison test. But since this series right here converges by the comparison test, I can finally proclaim that the original series this one right here converges. Absolutely. Since it converges absolutely, I can finally now conclude that the series in question converges. Again, because any series that converges absolutely converges.